Okay, so for these types of problems, what we want to end up doing is really kind of working in reverse. If you think about what we've been doing this unit so far, specifically in lesson 2, we've been trying to find the exact values of trig functions given an angle over here, right? So this is what we're doing in lesson 2. And our strategy was really not really to try to solve one of these problems. We want to relate it back to an angle that is between 0 and 90 degrees via something called the reference angle, which is the angle we make with the x-axis. So I just sort of scrolled over those on those two examples, right? And that's going to tell us the numerical value part. But then for these problems, there was also a matter of the sign, the SIGN sign, as in whether they were positive or negative. And as we remember from lesson 2, that depends on what quadrant we're in. And we have our little mnemonic, ASTC, all students take calculus, and the letters tell us which trig functions are going to be positive in which quadrants. And just to be specific, we mean which of the 3 regular trig functions, and obviously the reciprocals of those functions will be positive or negative in that respective quadrant as well, right? So like in quadrant 2, the sine is positive, and that automatically implies that the cosecant is positive as well. But the tangent, the cotangent, the cosine, and the secant are all going to be negative here. In today's types of problems, these ones are pretty easy for us, but what we want to end up doing is working in reverse. And we've done this with a lot of problems this unit, where we know how to work with the function one way, how to plug into it, and then get an answer out. But we also want to understand the reverse problem, which is kind of like the inverse of things. Because if we can understand it from both sides of the coin, we understand the problem a little bit better here. So when we're doing these problems here, we're going to have to, when we're working backwards, we'll try to relate it to that sort of like quote unquote forward problem we were talking about, where we needed 2 things always. I need to know the reference angle to tell me the numerical value part, and I need to know what quadrant I'm in to tell me whether I'm positive or negative. It's more or less the same idea here, except we're not really looking for the reference angle in this point. We could find it if we want. We could see what the actual value of theta is. But if we look at what these questions are saying, it asks for the exact value of the remaining trig functions of theta. So we're going to see in just a minute that we actually don't totally need to figure out what theta or what the reference angle of theta is. But instead, we can just relate back to the definition of these trig functions of the sine, the cosine, and the tangent, meaning that they are defined as the ratios of sides in a right triangle. If we have that, it becomes really easy to find the others, and we can sort of circumvent needing the angle at all there. Right? But the sine SIGN part, that part is still kind of the same. We need to know what quadrant we're going to be in, because that's going to tell us whether something's going to be positive or negative. So looking at this one here, number 1a, it tells us that the sine of theta is equal to -3/5, and the cosine of theta is equal to 4/5. Notice that the sine is negative and the cosine is positive. So with these problems, I like to start with the easy thing first, which to me is to figure out what quadrant I'm in over here. Right? It doesn't look like it's kind of telling you that, but it is, because there's only one quadrant that can have this unique combination where the sine is negative and the cosine is positive, right? Let's take a look at our coordinate axes here. We'll draw a little ASTC chart. Well, we know that the sine can only be negative down in quadrants 3 and 4, right? The T and the C here, right below the x-axis. So I know it has to be based on this information here in one of those quadrants. But the other thing this question is telling me is that the cosine of theta is equal to positive 4/5. Well, the cosine is only going to be positive in the first and the fourth quadrants. So between those two pieces of information, I know that I've got to be over here in quadrant 4. And if we're going through these problems and just to sort of mark it down each time, I find it useful to sort of put a check mark into any quadrants that satisfy either condition, right? So I would have put a check mark into the third and the fourth for the sine condition part. And for the cosine, I would have put a check mark over here and here. And only the fourth quadrant fulfills both of those, so it has to be in quadrant 4, right? That tells us that the cosine should be positive, and we know the secant should be positive as well, but all of our other trig functions should be negative. Okay, the next part is how to get the values of these. And if we think about it, actually, it says the exact value of the remaining trig functions. So we have the sine, the cosine, the tangent, the secant, the cosecant, and the cotangent here. So there's the 6 functions, but there's really only kind of 3 functions, right? Because yes, the cosecant, the secant, and the cotangent are defined as separate functions entirely, but their value is completely dependent on whatever the value of sine, cosine, and tangent is. So I don't totally need to solve for those. I just need to solve for the regular trig functions. And then I know that the reciprocal trig functions are just that, they are reciprocals. So I can take my answer from the regular trig functions and flip them. Right, so let's see how to get the actual answer part now. Right, well, first off, we know we're in quadrant 4. So with these types of problems, let's draw a terminal side of an angle somewhere in quadrant 4 over here. Okay, so that's where my angle is. We know, of course, though, that like even though this would be the angle we have that puts us over into quadrant 4, it's not that one we're looking at. It's this little guy over here, which is our reference angle. And like I said, we can try to find the reference angle and then plug that in, but it's actually easier for us if we relate this to the definition, meaning like, let's use SOHCAHTOA for this. For instance, I know that the sine of theta is equal to a -3/5. But I know in general, for any right triangle, the sine of theta is equal to the opposite side over the hypotenuse. Okay, so this is telling me that in some triangle, whatever triangle I can make from this here, the opposite side should have length 3 or -3. We'll talk about that in just a moment. And the hypotenuse should have length 5. So what we want to do is take our picture of where that terminal angle is and set up a triangle someplace. So there's a question of where should I make my right triangle? Should I draw a line up here or over here? But think about it. For all of these other problems, we always care about the x-axis. Remember, the reference angle, this one we just drew, is the angle we make with the x-axis. So if I'm drawing a right triangle to solve these problems, I need this little angle here to be within my right triangle. That tells me that the only way I can do this is if I sort of drop a vertical here and I create my right triangle with the x-axis. And that's sort of the second big piece of these problems that we need to remember in order to solve these. One is to figure out the sine part first, the SIGN sign. And the other is that when we're drawing our little reference triangle here, we always want to draw it by dropping a vertical down. So that would mean in like quadrant 2, for instance, if this was the terminal side of the angle, I would want to make this triangle over here. Again, the one with the x-axis, and then that would be my reference angle. Okay, but let's get back to this problem here. Like I said, now I have a little reference triangle to help me out. Let's just sort of play, let's match them up to what I'm told here to figure these out. So let's label our sides. We'll start with the hypotenuse. Of course, the hypotenuse is the easy one. It's the one opposite the 90-degree angle. Well, here's my 90-degree angle. We know a 90-degree angle is like a T or like an L thing, right? A sharp corner. Okay, so that means that this is my hypotenuse, or the terminal side of my angle is the hypotenuse. We know opposite means away from. So if here's my angle, this over here, the vertical side is going to be the opposite because it is not touching it. And of course, this is my adjacent now. Right now, it's literally just a matching column. So over here, sine is opposite over hypotenuse, which is -3/5. Well, then I'm going to, for this triangle, set it up such that my opposite side has length 3. And I want to put in a -3 here. We'll talk in just a second. And my hypotenuse has length 5. So I'll label those sides. Okay, and just take a note. I wrote in a -3 here. Obviously, triangles can't have a negative side length. That doesn't totally make sense. But remember, this triangle is within the coordinate plane. So it makes sense to put in the -3 here because notice we go down 3 units to create this triangle. So we put in the negative explicitly. So later on, when we are filling in our values for the trig functions, we don't have to worry about, okay, I'm in quadrant 4. This function should be positive. It's sort of built in for us. Okay, so now I have the opposite side and the hypotenuse. I need a way to find the adjacent. Luckily, this problem here is giving me that the cosine of theta is equal to 4/5. And we can do the same thing for cosine now, because cosine is the adjacent side of the hypotenuse. So this is telling me that the adjacent side will have length 4. And now I have all 3 sides in a right triangle. So finding the value of trig functions is really quite easy at this point. It's completely trivial if we're being honest. Right, so we can go ahead and figure out the tangent of theta. SOHCAHTOA tells me that the tangent of theta is equal to the opposite over the adjacent. So the tangent here will be equal to the opposite side, a -3, over the adjacent side, which was 4. And this is what I was saying before, that when we just throw in the -3 into our triangle based on the fact that we went down 3 units, I don't have to worry about making sure that the tangent gets the correct SIGN sign. I know that the tangent should be negative in quadrant 4. And it's just sort of built in. There it is, it's negative. Now for the reciprocal functions, it's even easier because I don't have to really think. All I have to remember is that cosecant goes with sine. Cosecant is the reciprocal of sine. So I'm just going to take whatever my sine value was and flip it. Right, so if sine is -3/5, cosecant's 5/3. Similarly, secant goes with cosine. So if cosine is 4/5, then the secant is 5/4. And obviously cotangent goes with tangent. So if the tangent was -3/4, the cotangent is 4/3, which is the same as -4/3. It doesn't matter where we put the negative sign, but that's how we get that one. Okay, and all of our problems are going to follow just like this over here, except they might just ask us or give us the information in different ways. So once again, they need to tell us, for these problems, we would need to know what quadrant we're in, because that's going to tell us relative signs, positive and negative. And we need to be able to figure out the triangle values. In the first one, they explicitly told us all three, but let's take a look at 2A for a second. We can play the same game. In this one, I don't have to even bother with the ASDC chart because it's just explicitly telling me I'm in quadrant 2. So I can draw my little reference triangle in quadrant 2. Drop down that vertical, like we said, such that this is my opposite, there's my hypotenuse, there's my adjacent. Sine of theta, once again, is opposite over hypotenuse, so this is 12 and this is 13. And now I don't have the cosine to go ahead and tell me what is the adjacent side, but let's not forget all the math we already know. We've talked about this several times in class. I'm in a right triangle, so I can always use the Pythagorean theorem to help me figure out what is that third side, right? Pythagorean theorem is sum of the squares of the legs is equal to the square of the hypotenuse. And if we were to do that for this one, we'd find the adjacent side is length 5. And then we'd be good to go to solve for this one as well. We would just set up our ratios. SOHCAHTOA, relate our reciprocal trig functions and flip them. Okay. Similar idea in like part 3 over here, 3A. On some of these, it doesn't explicitly tell me what quadrant I'm in, but if we look at like 3B, well, actually, it really does. It's not saying what quadrant I'm in by saying in the same way as 2A that I'm in this quadrant, but it tells me that theta is between 270 and 360 degrees. Me being someone who studies for my tests and knows my unit circle and my quadrant angles, knows sort of that each quarter turn is 90 degrees, right? So anywhere between 270 and 360 means that I'm over here, which is quadrant 4. So it didn't tell me that I'm in quadrant 4, but like, yes, it did, because it said my angle theta has to be in a range that can only be quadrant 4, right? And like parts C and D, they're kind of like a mix of the ones we've been doing. So this one's not telling me an angle value for the theta. It's not telling me explicitly what I'm in, but it is telling me what's positive and negative. It says sine is positive and tangent's negative here. So I got to find the quadrant where that's true. And then I can do the same game that I did over here, fill in some sides of the triangle and solve. And that's really it for these problems. These ones are kind of easy. As we saw, like most of the work's actually done for us because there's only 6 functions. If they give us at least one of them, they're giving us like 2 sides of a triangle. We only need the third. But that's it for this one.